Dear students, welcome back to the video lecture series on embedded systems. This is lecture number 5. In the previous lecture, we have discussed about the various units in the architecture of ARM Cortex M3 in detail. And in today's lecture, we shall take up the new topic, that is debugging support. Okay. So first, before going into the actual details, first you should know what is the meaning of debug. Okay, so if you just split the word like d and bug, so bug means it is like an error. Okay, so how to overcome this error? So if you are able to overcome that error, so that thing is called as debug. Okay, so there will be two kind of approaches. One is software, another one would be hardware. Okay, so we shall discuss here the available options which the Cortex M3 supports. Okay, so first, the Cortex M3 processor, it includes a number of debugging features such as program execution controls, so which include halting and stepping, instruction breakpoints, data watch points, registers, memory accesses, profiling, and traces. We shall discuss these things one by one. So, before going to the other details, so if you look into the next few points, the debugging hardware. Now, if you consider the hardware aspect of Cortex M3 processor, it is based on a concept called as core site architecture. So that means core site architecture means if you consider the previous, that is traditional ARM processors, the CPU core itself does not have a joint test action group interface. So there is another new word for you, JTAG. Okay, so that also I will cover. So if you observe previously in the previous slide, we had a diagram like this. So that was the JTAG. And this picture, what you are saying, this is called as the bus, which is usually used to provide the connection between the device and the interfacing device, or the processor and interfacing device. Okay, so instead now what is the available option? Instead of JTAG, what they do, a debug interface module is decoupled from the core. So decoupled means detaching, taking away, or departing, that is dividing it from the original connection. Say for example, if in your computer system, if the computer is booting, means the motherboard is working, if there is any hard disk problem is there, if the RAM is having some problem, so then what you can do is you can disconnect the RAM temporarily. So that disconnecting process is called as what? Decouple. Okay, from the core. Core means it is the CPU or the processor. Okay, so once it is disconnected, and a bus interface called as debug access port is provided at the core level. So there will be alternate slot for the RAM. If I take an example, so the same RAM which you disconnect, so that can be again reconnected to the other slot which is available in the motherboard. Okay, This is one example. Another uh, means a simple example which you can understand easily is like a mobile. So if you take a mobile charger, if it is having a USB charger, so once you connect the mobile to the charger, so if you observe that you are not able to see the message or some indication of charging, so what you can do, what you can, how you can debug that. So first option is you can check the charger. You can take off the USB cable. You can use other cable to check whether the charger is working or no. So if you connect through another cable with the same charger, if it is charging, so the problem will be with the cable. So like that, here also you can decouple it from the core and you can reconnect it, the same component which you are going for a debug, through another slot or another interface called as debug access port. Okay, so through this bus interface, external debuggers can access control register to debug hardware as well as system memory, even when the processor is running. Okay. So there are few things here. Again, you can take the example of the mobile. So while you are working on your mobile, so if you get some updates for various application or various operating the operating system, so in such cases you can allow the updates to run in the background. The updates are running in the background. So that means what? External debugger can access control register to debug hardware as well as system memory. So what example I gave you, no, it is related to system memory even when the processor is running. Okay. So another example which you can understand is like you can keep the mobile in on state. Nowadays we have the SIM slot as SIM trays. You can pull out the SIM tray. You can again insert the new SIM, or you can insert the memory slot, memory card also if the memory slot is there, even when the mobile is still on. You can do that. But earlier systems, I mean earlier mobiles, if you have used them, so if you want to change the SIM or insert the memory card and all, so you need to actually turn off the mobile, or you have to take the battery. Below the battery you will be having the SIM slot and other things in the earlier days, correct? So here also nowadays what has happened now? So there is a new technology. You can still keep the device on and you can insert the SIM, and even you can take off the SIM or the memory card. Same thing is applicable here also. That is the meaning of what? Through this bus interface, external debugger can access control register to debug hardware as well as system memory, even when the processor is running. So I hope this example is clear to you. So we shall come back to these points one by one. That is about the software debuggers. Okay. Next. Okay. So as I told regarding the software debuggers, we had various debug options available there, correct? So one of uh, them was, if you remember, that is namely program execution control. So if you consider this example, that is program execution control, the meaning of, so in short I will be writing it here, that is program execution control. So program execution control means if you have, let's say, 1, 2, 3, 4 line of instructions. So if you want to see how these 4 lines of instructions are executing. So under the program execution control, we have various debugging options. One of them is halting and stepping. So if you consider the first one, that is halting and stepping. Okay. So if you consider the halting and stepping here, that means, as I told, we have 1, 2, 3, 4 line of instructions. So if the system is executing, say, assume that third line of the instruction, so you can stop it or you can halt it temporarily to see what has happened by these 3 instructions, which all changes have happened. So you can halt it, means you can temporarily stop it. And you can, one more you have is stepping. So if you have another set of instructions, let's say 5, 6, 7, 8. If you don't want to execute instruction number 4, so if you want to skip it to instruction number 7, so in such case also you are allowed to do that. So it will be like single step or like one step only. Single step means one by one instruction will be executed, and you will be able to see the result parallelly also. One step means after initializing the first instruction, directly it will give you the result. Okay, that is the meaning of what halting and stepping. So I hope this is clear to you. Okay, so second feature in program execution control is instruction breakpoints. Okay, so instruction breakpoint, I will come to that also. And one more is data watch point is there. Okay, so let me write that also, data watch point. So if you consider the meaning of data watch point, so data watch point means, say if you have executed some instructions, some 10 instructions. So after executing this or while executing certain instructions, so processor should understand whether the user has given the data suitably. That means, say for example, if the processor or controller is of 8 bits, okay, so 8 bits means what? Any register, anything, if you consider, it can accept 8-bit data only per instruction. Suppose if you give a 10-bit instruction, so how processor should tell to the user that you have given the data more than the capacity of the processor or controller. Okay, so that is nothing but what? Data watch point. So one example, if you consider with respect to this, so we know R0 to R12, they are general purpose registers, and they can hold 32-bit data maximum. So if you give something like 64-bit data directly, so capacity itself is what? 32-bit. You are giving double, so it cannot accept that directly. So in such cases, the what you say, the software which you are using for writing the program or executing the program will be able to give you this error kind of messages. Okay, so this is about the data watch points. Okay, so similarly, if you consider the most important aspect here is about the instruction breakpoint. This is one of the very beautiful feature and as well as very important one also. So instruction breakpoint. So that means what? If you read in reverse way, that is what we have, what you are breaking is instructions. So here, if you are able to see this example, there are 1, 2, 3, 4, 5, 6, 7 instructions. Seventh one is having what now? JNB, jump if no bit. So with respect to label and location, so it should check in the location 401378, and after confirming all those things, it should come back here, the green one, what you are seeing. Okay. So how it is done? You just remember this figure. So it will go to this location first, that is 401378 location. So you can see here 401378 location. So what happened now? Instruction which should take certain decision, it has to wait for a while to check the condition or to check the data which is available in some other location. So if you consider this also, what is happening here? It is checking whether there is a bit. If there is a bit, if there is no bit, it should come to this location. So it is checking that is there any bit value is there. So what is the JNB means? Jump if no bit means zero value. So it is as good as JZ, jump if 0, where it should jump to location 4013E2. Again it should go back there. So this will continue here again. Okay, if it is there, it will continue. So like that, it will continue in between the instructions. Or if you consider like move a comma or move add r1 comma r2 also, r1 will be having some certain memory location. It should go to that point, that location, and check data is available or no. Then it should go to r2 location, it should check the data, then it should add. But these things will happen in a very quick time. Okay, so if you execute the things step by step, you will come to know about that. Okay, so this is all about the instruction breakpoints. Okay, so further you have something called as profiling also, memory access. Profiling, profile means what? User profile. What are the properties? Something like your if you take your profile, Facebook profile or any other profile, it will ask you the name, certain fields and all about you, right? So similarly here, if you consider the profiling, it is related to the memory location or the memory status, whether a particular memory which is required to be used by the program is having some data or required data. Okay, so if you are using a counter as a register, so that register where it is located, that memory should have uh, those many count values, and after uh, meeting the required condition, the counter value should go down. So if certain things are there, such things are there, so then the profiling will be checked. with respect to memory location. Okay, that is about the instruction breakpoint. So continuing the previous thing, that is about the hardware breakpoint, the control of DAP, debug access port bus interface is carried out by debug port. Okay, it is simple. The debug ports currently available are serial wire JTAG debug port, so which I shown you earlier. Then another one is supported is called as supports the serial wire protocols only. Okay, that is serial wire protocol. So there are two types: serial wire JTAG debug port, okay, which supports the traditional JTAG protocols as well as serial wire protocol. Another one is serial wire DP, which supports this one. Okay. Other than that, what is the other option is the manufacturer itself can also include an embedded trace microcell. In short, it is called as ETM to allow instruction trace. Like we discussed earlier, single step instruction. Same thing here also. Tracing information, right? So that is done through trace port interface unit. How that instruction is getting executed step by step, which all registers are involved. It is called as tracing. So if I want to trace the mobile, what are the criteria I should include? That is mobile number, location, correct? It may be in same location for longer amount of time, or it may be changing. So the same thing here also. Certain register or memory that can be checked. Okay. So these are the few debugging supports which are available in Cortex M3. Okay. Other than that, there are certain events which can trigger the debug actions. So those things are debug events, can be breakpoints, watch points, fault conditions, or external debugging request input signals. So breakpoints and watch points we discussed. Fault conditions. Say fault condition in the sense, if you're unknowingly or knowingly if you use invalid instruction, so the user should come to know that. So where that error is happening. So that is called as fault condition. Or if in terms of hardware, if the cable is not working, if the communication is not happening, that is also the fault condition. Or external debug request, that is the same thing again what I told. So if you are taking the UART as an example, whatever the user is sending, same thing should be communicated. Say if you take the example of keyboard, if you press certain key, that key should be displayed, not the other key. If something else is getting displayed, so it means what? Externally connected device is unable to send the required data. Okay. So the data watch point function is provided by data watch point and trace. In short, we call it as DWT unit in the Cortex M3 processor. So what is the use of this? This can be used to stop the processor or to generate the data trace information. Okay. So as I told with the example earlier discussion, that is, if you go to mobile application, so if you have updated your operating system, so it will ask you to restart the mobile, correct? So if you restart the mobile, so what is happening? For a very short amount of time, the processor is halting. So that is nothing but it can this can be used to stop the processor, correct, or to generate the data trace information. Okay, so this is all about the debug support. Okay, then one more feature is like the using the RAM. So in addition to the basic debugging feature, the Cortex M3 processor also provides a flash patch breakpoint unit that can provide a simple breakpoint function or remap an instruction access from flash to a different location in SRAM. Say, if you have experienced one condition, that is, if you are working on certain things like a Word file or some PPTs, so if you are saving the your work on the timely basis, so then it is fine. Otherwise, if due to some power fluctuations and all, if the system is restarted, so nowadays now if you go to the any PowerPoint and all, it will take you back to the last saved condition, okay, or lastly worked condition. So how it is possible? Whatever you are working, that data will be saved temporarily in the SRAM. So this allows the user to even to stop the data loss also, correct? So in that way, you can even save the time and you can switch back to the last step where you have stopped working or where you have stopped the execution. So without the need for rewriting the entire instructions again. So this is called as the one of the debugging support, and an instrument called as instrumentation trace macro cell provides a new way for developer to output the data to a debugger. So this is how it is used. Okay, so these are the concluding remarks about the debugging support.